Okay, we are now on to Chapter 9. Chapter 9 continues to take classes and objects and moves them a little bit further along and starts to add some of the extended features that are available in Java in order to make classes and objects a little bit more powerful. And I'm adjusting my camera here a little bit. I keep having to adjust it because I wiggle a little bit and my hinge on my laptop's not that strong. You need to make sure that you've done the previous class's assignment first, the previous chapter's assignment first. Otherwise, this is not going to go well. You won't be able to complete this assignment this time around if you do not deal with the one previous first. And that's been a very general theme of this class up until this point. Just keep in mind that you need to keep in order. Don't try to go out of order. So if you haven't completed the previous classes videos, the previous chapters videos, you need to go back and deal with that before coming here. That being said, this week is about inheritance and interfaces. And in fact, the next 2 weeks will be about inheritance and interfaces. This is actually what we're going to be finishing out the class on. These are slightly more advanced topics. These are probably intermediate level topics, and I don't necessarily expect you to come out of this one with a complete and total understanding of how everything in this situation works, but some of this will be helpful for you in the future, so I want to make sure that we cover it. The first thing that I want to do is I want to talk a little about interfaces in a very general context. Take a computer, for example, either a desktop or a laptop, and think about how you would normally interact with your average computer. Do you use a touch screen with your home desktop? What about voice commands? Motion controls? Probably not. Most people nowadays interact with their computers through either a mouse and keyboard. Through a mouse and keyboard, not through either. Through a mouse and keyboard. There are specific special case circumstances where some people may interact with their computer with voice commands, like with Cortana or Siri on certain Mac products. You may also have a touchscreen on your machine, but for the most part, the go-to interface for a computer has always been the keyboard and mouse, at least as long as we have been alive. So, that being said, the keyboard and mouse is our common interface for interacting with the system. It gives us certain abilities on each system, like typing and clicking, that allows us to actually perform more complex tasks. And it's the same idea with interfaces in Java. It's just sort of on a lower level. So the first thing that I want to do in this class is explain specifically how you might create an interface for you to work with. And we're actually going to create one called Speak. Now, what you do is you go into your BlueJ project window, and you can either do right-click New Class, or you can click New Class, and it will bring up this window, and we're going to call it Speak. But one thing that you're going to want to remember to change is this class type button, because an interface is sort of like a class, but we'll see how it differs here in a minute. So I'm going to click that radio button, and I'm going to click OK. And we can see that it looks a little bit different than what we're used to. It has the word interface at the top, and Speak is sort of pushed down a little bit, but it still has the same general look and feel. And we're going to open it in the editor, and we see that we got some junk in here. We're going to get rid of it for now. And what I'm going to do is I'm going to write public void say something. Okay? Now you may be wondering, is this it? And I'm going to say, yes it is. In this instance, our interface doesn't have too much in it. This is just a general example that I wanted to show you guys. But I wanted to make this a little bit more clear in this way. basically there are some very big obvious differences, and then there are some more subtle ones. The first thing is, rather than put class here, we put interface. This just tells Java that this is what we are creating, this is what we are trying to accomplish. This is not going to be a full-blown class. This is going to be an interface for interacting with objects, so that multiple objects can implement this interface and make use of it. And obviously it has a name, it has a visibility modifier. That should all be fairly familiar to you by now. And then we have this method header with a semicolon at the end of it. And you may be wondering why there's no code with it. An interface is literally just that. It is trying to design an interface of how to interact with an object that implements it. So you don't actually really define any blocks of code. You're just trying to define the method names, the method headers that will be used in order to actually interact with the objects that implement it. In this case, we have a very simple method called saySomething. It's public, it doesn't return anything, and it takes in no parameters. And this is what we are going to implement in order to actually make our program work the way we want it to. Now the next thing that I'm going to do is I'm going to create two classes. I'm actually going to pause in order to do this because it will take me a minute or two to actually do this. And I don't see a reason to show you this portion of it. We will talk about the differences between your average class and a class that implements an interface after I've gotten it all written out and I don't have to talk while I'm writing. Alright, so now that I've got everything built up here, we obviously have our interface. We talked about that before. First class that I created was one called dog. Obviously it has public class dog, it has a constructor even though it's empty, it also has a toString method. This should be fairly familiar to you from the last class. And then we see that we have this implements speak here. So this is actually how you would make it so that a class makes use of an interface. You would say the word implements immediately after your class name, and then you would actually list the interfaces that you want to use. And you can actually use more than one interface by separating the interface names with commas. So if we wanted to use something like comparable, which we'll talk about here in a couple of minutes, this is actually how you would do that. This makes it so you can use more than one interface with a particular class. But we don't have a reason to do that. So this is how you would generally tell Java that you want to make use of the speak interface. Now, one thing to keep in mind, that if you want to make use of an interface, you have to implement all of its methods. You can't just pick and choose. You have to define code for every method header that is in that interface. Otherwise, Java won't let you compile your program. Period, end of story. Even if it's empty, it still has to be there and it still has to be defined. Otherwise, nothing is going to work. But that being said, we have the same method header that we had before in our interface. Obviously, sans the semicolon. And we have a block of code. In this case, all we do is we say system.out.println woof. Should be fairly straightforward to you, and this makes it so that we can access our dog class in a common way with other classes that we create that also implement speak. So let's look at person. Person also implements speak. It's in the same format as dog. It has a constructor. It's empty. It has a toString method. It has a class header, and it also has the implement speak, and it has our method definition for saySomething. In this case, we say hello instead of woof. Obviously, it wouldn't make much sense if a person walked up to you and said woof. basically what we're doing here is we're just trying to create that sort of common interface like we have with a mouse and keyboard, except in code. We have a sort of inbuilt system for connecting things together. Now, let's see this implemented a little bit. So let's say dog equals new dog, and person equals new person. Okay? And we can say dog.say something, and we can say person.say something. And if we compile this, and we look back here, we actually see that we have a bunch of new lines. Specifically, we have is a relationship, these arrows here. These are is a relationships. Person is a speak, is able to speak. Dog is able to speak. And then main has uses relationship, has a. So main has a person, main has a dog. Okay? We talked a little bit about that in the previous class. Has a and is a. Is a is the big one where we sort of try to define objects as other objects. That goes back to that thing called polymorphism, and we're just not quite there yet. I will make a little bit more mention of it here in a second to show you a neat trick of polymorphism in Java programming, but I'm not quite there yet. But that being said, if we run our main program, we see woof and hello, okay? Which is what we should see. The say something methods are defined as such. Now, we could create more objects like cat, bird, what have you, in order to do this, but you may be wondering at this point, what is the point? Why have these interfaces? What makes them so powerful and so useful in Java? Well, just like with a computer, you can walk up to any computer and know that it's a computer simply because it has a mouse and keyboard. You know that it's there. You know that you can use it, so you know what type of interface you have and what you should expect it to be able to do. So let's look at that from the context of Java, and specifically in the context of how we might implement this to make our programs a little bit more dynamic. Reading rainbow style, you know, the more you know. I don't know why I'm talking with my hands so much today. So let's get rid of this stuff. And what I'm going to do, which if I could get everything to stay highlighted for once, there we go. What I'm going to do is I'm going to create an array. I'm going to create an array of objects called speakables. Okay? And we're going to set it equal to a new speak array, and we're going to make it 4. Okay? And what I'm going to do is in each index, I'm going to create a new object that is something that has the ability to speak, something that implements the interface to speak. Okay? And then what I'm going to do is I'm going to say for int I equals 0, I is less than speakables dot length I plus plus, and then I'm going to say speakables I dot say something. Now, you may be wondering how this is possible, and this sort of starts to lead us into talking about polymorphism. Remember how I talked about is-a and has-a relationships? Well, both dog and person are objects that can speak. It is an is-a relationship. Dog is a speak. Person is a speak. They implement the same interface. So what we can do is we can actually reference them in the same way just by creating a variable type, in this case an array of speaks, that they both implement. Now this may seem kind of fuzzy to you, it may feel a little uncomfortable, but you can see that when I compile, there are no syntax errors. This is because we are storing stuff in the array that is available to us as a common interface for all objects that implement speak. Okay? All classes that implement speak. So anything that is also something that implements speak can be stored in this array. Now, does that mean that it's still a dog? Does that mean that it's still a person when it's stored there? No. If we create, let's say, a method called public void walk, and then say system.out.println I'm walking for person, and we try to call speakables I dot walk in here, Java will give us an error because in the speak interface there is no method called walk, and that is what Java is looking for. It is looking to the speakable interface and saying, okay, what do I have to work with this interface? So let's see what this does. Really what we should expect to see is woof, hello, woof, hello. So let's compile, and what we'll do is we'll go back and we'll go void main string woof, hello, woof, hello. So you can see how this might be useful in programming because we can sort of generalize an interface for a bunch of different objects that all might try to complete similar tasks, just maybe in a different way, and then make use of them by calling on that common interface that they actually implement in order to store them and work with them, as opposed to having multiple different mechanisms for trying to deal with whatever it is that we're trying to deal with. In this case, trying to get a whole bunch of objects to speak, as it were. Now, we'll talk a little bit more about polymorphism next time. Polymorphism is one of those things that it takes a really long time and a lot of examples for it to really click for people. I know that it took me a little while to sort of understand and see what the benefit of the polymorphism idea really helped to do. But that being said, we do have 2 more videos to do. I need to talk about comparable, and then I need to talk about the assignment, because the assignment requires comparable in order for you to complete it. So what I'm going to do is I'm actually going to pause. I'm going to create another class, and we'll talk about it when I start the next video, and we'll also talk about comparable and cover what specifically this whole comparable thing is all about, so that you can do your next assignment.